Now, I think we actually already did a little bit of practice with finding inverses because that is on the quiz today, but we're going to do it again. So try to pay attention here. We're going to try to find the inverse of log base b of x. That's a b, not a 6. It wouldn't matter if it's a 6 or a b, but it's a b. What's our first step to finding an inverse? Okay, substitute y for f of x, right? Y equals log base b of x. Okay, then what? Switch the x and the y. X equals log base b of y. Then what? Square both sides? No, you only square both sides when you got a square root, right? You can't divide by log b. That's like a function notation there. Convert to an exponential. What would the exponential be? What's the base of the exponential? B. What power is it being raised to? X equals y. So by converting it to an exponential, we did solve for y. So the inverse of a logarithm is the exponential. Logarithms and exponentials are inverses. That's why they're taught together. That's why we learn about inverses before we get to this part. Logarithms and exponentials are inverses. Now, what that's going to mean for us, the reason that they present it here is because you don't have on your calculator, if you had an 83, you didn't have any other way to graph a logarithm that wasn't base 10 or base e, other than first graph the exponential, then switch all the x and the y coordinates and plot those points and graph that. If you look in the book for the next example, that's exactly what they do. Okay, you kind of don't need to do that anymore. Right? If you wanted to graph an exponential or a logarithm of any base, you've got the log base function in your calculator, so you can do any one. We really don't need it for that. Where we need this kind of thing is for, specifically when we have to solve the kind of equations like the sine of x equals 23 over 45. Solve for x. Again, this is a function notation. You can't divide by SIM. What you do is you take the composition. You say sine inverse of sine of x equals sine inverse of 23 over 45. Right? This is another part of our quiz today. When you take the composition of a function and its inverse, in some cases, and this case is one of them, they cancel each other out. The sine and the sine inverse cancel each other out, and all you get is x. Do you remember what was the situation? What had to be true for this to happen? That the composition cancel each other out. It had to be that both the function, in this case sine, and the sine inverse passed a vertical line test. When that happened, then we could do that. Do you remember the homework that we had last time? The last 4 problems where in every case the answer was whatever was in parentheses. That's it, okay? When we did it, it was because our function was linear that we knew that was true. But there are other functions that work that way. Logarithms and exponentials work the same way. And that's why you learn about these together, because when we get a logarithmic equation to solve, which we won't now, we'll get it next semester, we will use exponentials to solve it, just like we did here. Or if we get an exponential equation to solve, we will use logarithms to solve it, right? So that's why this property that we use really just for silly things is so important. And it's why we learn about logarithms and exponentials together.